Hello, everyone. I wanted to teach you about balanced and unbalanced forces today. We are going to look at a Google slide of balanced and unbalanced forces. This first slide here is a good one to come back to later on and push play and watch the video that teaches you more about that. Next slide. We are going to learn first about balanced forces. Now, a balanced force is a force that is equal in size and opposite direction. So we know that a force is a push or a pull, and neither object on a balanced force moves because it is equal in both directions. So we have two guys here, and they are pulling the rope, and they are both pulling equally, and the rope is not moving. Here we have two people arm wrestling, and they are pushing, equally. They can feel the force, but they are equal on both sides and they are not moving. So these are balanced forces. Now we're going to remember back into our energy units when we learned that something that is not moving has potential energy. So balanced forces have potential energy. There's the potential to move the rope. There's the potential to win the arm wrestling match. But right now they're balanced and not moving. Let's move on to unbalanced forces. An unbalanced force is a force that can occur when one force is greater than the other force, the opposite force. This greater force causes the object's motion to either speed up or stop or start or slow down. The object moves in the direction of the greater force. So think back to the arm wrestling situation you just saw. If one person is pushing harder, he is going to win. If one person is pulling the rope harder on the tug of war, he or she is going to win. The unbalanced forces cause a non-moving object to start moving. They also affect the rate and direction of motions of objects. Now, an example of an unbalanced force is this. This little blue car is stuck. We don't know what happened, but the engine quit. Maybe the tire went flat and he needed to be towed. So this Jeep came to the rescue, hooked a rope to the blue car, and the Jeep was stronger than the blue car. So the Jeep was able to have an unbalanced force on the blue car and move the blue car to the repair shop. Now, how do you calculate with math a balanced force? You calculate forces that are balanced by subtracting the opposing forces. So let's just take the example of this toy truck. Someone is pushing the toy truck in one direction. Someone is pushing the toy truck in the other direction. So we want to look and see, let's just pretend that this person is pushing the toy truck with 100 newtons. And let's say this person on the other side is pushing the toy truck in the other direction with 100 newtons. So you would take 100 minus 100 and you get a 0. When you get a net force of 0, that means the object is balanced and there is no motion. All right, let's move on and figure out how to calculate an unbalanced force. When you have an unbalanced force and the forces are going in the same direction, you're going to add those forces together. This moving person is moving the couch with 25 newtons to the right. This other guy is moving the couch with 20 newtons to the right. So you would add 25 newtons plus 25 newtons, 20 newtons, 25 plus 20 is 45 newtons. The couch will be moved to the right. So these are unbalanced because the couch is moving. They have kinetic energy in the amount of 45 newtons to the right. Okay, let's remember our lesson about unbalanced or balanced forces. If something is balanced, it is not moving. This gymnast, she is balanced on the balance beam. She is not moving. She has potential energy. This gymnast is not balanced. She is very unbalanced. She is moving off the balance beam very quickly. She has kinetic energy. Thank you for listening about balanced and unbalanced forces.